Hi there, in this video we're going to be solving the following problem. Find c so that the function, and then we have some piecewise function, is continuous at x equals 4. So to solve this, we're going to be making use of limits, or at least the logic of limits. Now notice that this piecewise function here, if I actually try to graph it, it would at x, let's say this point right here was x equals 4. If I graphed it, at x equals 4, it's going to take on the roles of the different type of function, this one right here. And clearly this is not continuous because it has a branch off point. So the question's asking, what c value can we possibly have so that this function would be continuous? Well, this is where the logic of limits comes in. Notice that if we took the limit as for this function right here, as x approached 4 from the left-hand side, so the limit from as x approaches 4 from the left-hand side, to denote that, we put a negative sign there. So that means just as x is approaching 4 from this side, what number should it equal? Well, it should equal 4. And as such, if you went from the right-hand side and you took the limit as x approaches 4 from that side, so as x approaches 4, then you put a plus sign because you're coming from the right-hand side. So if you were doing that, what would that equal? Well, it should equal something that it should equal exactly this number up here if it was continuous. But because this particular piecewise function isn't continuous right now, it's going to equal some other y value at this point. So in order to do this, we have to make this right here equal this one down here. So then what exactly do we do first? Well, as x is essentially less than or equal to 4, taking on this particular role right here, whenever x is less than or equal to 4, what do we write down? Well, it's right here, cx add 5. Let's write that down. And in order for it to be continuous, this portion right here has to equal the right-hand side, or this portion, or this part down here. So whenever whenever x is greater than 4, and whenever x is greater than 4, the piece of the function we use is x squared add 2. So basically this is saying, in order for this piecewise function to be continuous at x equals 4, the limit as x approaches 4 from the left-hand side has to equal the limit as x approaches 4 from the right-hand side. If they don't, then you have a jump and it's not continuous. So this has to be true. And because we're doing it for x equals 4, this x value right there is going to be a 4. So if I just rewrite that, it's c4 add 5, or just 16 add 2. So I'm just going to put an 18 right there. And now let's just solve it for c. So I'll put the 5 over there. It's going to give me a 13. And then if we divide both sides by 4 after that, c is going to equal 13 over 4. And that is the answer. That's the c value you're going to need in this piecewise function for it to be continuous. That's the only instance where this function here can be continuous, is if that one value, that one variable, c, is 13 over 4. Well, I hope you learned something. If you have any questions, feel free to ask in the comment section below. And of course, I do hope you're having a fantastic day.